Okay, we will start soon. Wait for few minutes, then we will start from the beginning. If you have any doubt, you can ask me. So, Darsan, let's start. Haloalkanes and haloarenes. I think I have taught you this chapter. Just wait a minute. So, see, Darsan, this is basically haloalkanes and haloarenes, first chapter of organic of class 12. So, there is two terms basically halogen and alkanes. Halogens and alkanes. So halogen is also known as halo group and it is denoted by X, that means fluorine, chlorine, bromine and iodine. And alkane, you already know, it is hydrocarbon alkane. So haloalkane can be written as Rx. Rx is haloalkane, or in common name we can call it alkyl halide. In the same way, here it comes haloarenes. Halo means again fluorine, chlorine, bromine, iodine, and arenes means basically aromatic compound. Arenes comes from aromatic, and in this chapter in class 12, arenes means basically benzene. Benzene is an aromatic compound. This is basically benzene. So this is benzene, and if there is X, this is called haloarenes. So first of all, we are going to classify. Wait a minute. Madhiya. So we just started haloalkanes and haloarenes. Haloalkanes, that means Rx, can denote it by Rx, and halo means halogen, alkane is hydrocarbon, and you can see the next is haloarenes. Arenes is basically aromatic, and in this syllabus, arenes we will take as benzene. Benzene is also an aromatic compound. So this is haloarene and this is haloalkane. So first of all, we are going to classification, and the classification is classification depends on what base we are going to classify. Like in this class, I can classify on the basis of gender as well as on the basis of marks you obtained in the test. So basically this classification, first classification is based on the basis of number of halogen atoms. On the basis of number of halogen atoms, that how many halogen atoms in this compound is, on that base we are going to classify. Can I change the slide, Madiha and Darsan?
Yes, sir.
Okay, now you can see on the basis of number of halogen atoms, I am going to classify it like the first one is C2H5X. If there is only one X, if there is 2X in the compound, and if there is 3X, if there is 4X, X that represents halogen. So here it is CH2X CHX, CH2X. Now you can see this is what we call it mono halo, that represent only one halogen alkane, mono haloalkane. The second name is dihaloalkane, and the third's name is trihaloalkane. So this is the first classification on the basis of number of halogen atoms. In the same way, we can classify haloarene like this is 1X, that means monohaloarene. Monohaloarene. The second one is you can see the second, there is 2X, that means dihaloarene. And if there is 3X, 3 halogens, that means trihaloarene. So this is the first classification, which is very easy, very, very easy. Please write it. After this classification, we are going to start degree of carbon. Please write it and let me know when you are done with this. Let me know when you are done with this. Very good. Madhya, are you done with this?
1 minute, sir.
Okay.
Done, sir.
Now before the second classification, I would like to ask, do you know how to calculate degree of carbon? Yes or no? Just answer me. Have you studied this in class 11? Very good. Madhya? So degree of carbon is number of carbon directly attached or connected. Degree of carbon is equal to number of carbon directly connected or attached. If we have a compound like this, if we have a compound CH2 and then CH, here it is CH3 and then CH2 and then C, and here it is CH3, again there is CH3 and then CH3. So how we are going to calculate the degree of carbon? See, I am going to calculate the degree of each and every carbon. This carbon directly connected to this carbon, you can see directly connected to only one carbon, this carbon. So it is 1 degree. But this carbon is directly connected to 2 carbon, left or right. So it is 2 degree. This carbon is directly connected to 3 carbon, 1, 2, and 3. That's why it is 3 degree carbon. This carbon is directly connected to only one carbon. That's why it is 1 degree. In the same way, this is 2 degree, this is 4 degree, this is 1 degree, 1 degree, and 1 degree. So this is how we are going to calculate the degree of carbon. So to how many number of carbon it is directly connected to, we can write to how many number of carbons it is directly connected. If it is directly connected to one carbon, that means 1 degree, or we call it 1 degree, or we call it primary. Primary. 1 degree is also known as primary. 2 degree, that means secondary. And 3 degree, that means tertiary. Up to this, very important. And 4 degree, that means quaternary. Is that clear, Madiha? If it is clear, please do find the degree of each and every carbon in this. Please do this and let me know. I'll just answer it after your solution. Are you done with this, Madiha? Done. Very good, Darshan. See, it's very easy. If you are going to see this carbon, this is directly connected to 2 carbon. So this is 2 degree, 2 degree, 2 degree, 2 degree. If you are going to see this carbon, you can see it is connected to this carbon as well as this carbon and this carbon. So it is 3 degree. And if you are going to check this, this will be 4 degree, this will be 1 degree, as well as this will be also 1 degree. This will be also 1 degree. If you are going to check this, this is connected to 3 carbons, left, right, downward. So it will be 3 degree. This will be 2 degree. It is connected to 2 carbons, and this will be 3 degree. This will be 2 degree. This will be 2 degree. Is your answer correct, Darshan? Very good. Madhya, why you are not responding? Are you there?
Yes, sir, I'm there. I got it correct.
Okay, very good. So I'm going to change the slide and we'll come to degree of halogen. So see how we are going to calculate degree of halogen, and degree of halogen equals to degree of carbon to which halogen is attached. Degree of carbon to which halogen is connected or attached. So it is very easy. If you have to calculate the degree of halogen, You just need to calculate the degree of that carbon to which halogen is attached. Like if we have a structure like this, wait a minute. If we have a structure like this, just let it. So you can see, if you are going to calculate the degree of this chlorine, that is halogen, so you need to calculate the degree of this carbon, which is 2 degrees. So we can write 2 degree halogen also. So both of you are going to calculate the degree of each and every halogens. Calculate the degree of halogen. And you know, 1 degree, 2 degree, 3 degree.
Done, sir.
What is the degree of chlorine? This is 2 degree. Nadia, what is the degree of bromine? This is 3 degree and this is 2 degree bro. Yes or no? Everyone done with this? Very good. Now we'll come to the next classification, that is second classification. Compounds containing sp3CX bond. X is equal to fluorine, chlorine, bromine, and iodine. So basically, this classification is about to which X is connected, to which carbon, to the carbon which X is connected is basically must be sp3 hybridized. And in this, we have 3 subpart of this. The first is basically alkyl halides or haloalkanes. Alkyl halides or haloalkanes, that is denoted by Rx. So basically this is very easy. CX, hydrogen, hydrogen, and this is R. R, that means alkyl group, that means carbon containing group. Methyl, ethyl, propyl, butyl, it can be anything. So you can see, just let me know the degree of halogen. Just let me know the degree of halogen here. Darshan, can you tell me the degree of each halogen? 1 degree, 2 degree, 3 degree, also known as primary halide halogen, and then here secondary, and then tertiary. Are you done with this? Just let me know when you are done with this. Darshan. Yes, very good. Now the second part of this subpart is basically allylic halides. Madhya, are you there?
Yes, sir. I got disconnected.
Okay, no problem. So are you done with this, right? Degree of halogen.
Yes, sir.
Now we were studying about the second classification. Compounds containing sp3-CX bond. That means basically to the carbon that X is connected must be sp3 hybridized. So this second classification has further three parts. The first part is alkyl halides or haloalkane. Alkyl halide is common name and haloalkane is the IUPAC name. On a okay, now see, this carbon is connected with one X, two hydrogen, and one alkyl group. That means carbon containing group, methyl, ethyl, propyl, butyl. It can be anything. So you can see this C is only connected to one carbon group, that is primary, because it is 1 degree. This is 2 degree because it is connected to two carbon group. This is connected to three carbon group. So that's why it's 3 degree, also known as tertiary. Please write it and let me know when you are done with this. Madhya, are you done? Just let me know when you are done. Am I audible to you?
Yes, sir.
So basically, you have already studied this topics.
Well, sir.
Okay. So we are here for allylic halide. See what is allylic halide? Since it is a part of sp3 CX bond, that means to which carb to the carb you can say X is connected to that carbon which must have hybridization X, which must have hybridization sp3. So the main point in allylic halide is that you can see this is CH2X and it has singly bonded here. You can see carbon making 4 single bond. Whenever carbon making 4 single bond, that means it is sp3. And adjacent carbon to this carbon must have doubly bonded, double bond. So this carbon will be known as allylic carbon, and the compound is known as allylic halides. So I'm going to again repeat this. So this is the doubly bonded, and then this is the carbon to which X is connected, and you can see this C is the adjacent carbon to this C is this, which is doubly bonded. This is also allylic halide. I can also write like this. This is X and adjacent carbon this, or you can take this, or both you can take. This is allylic halide. Got it? Because this to this carbon has hybridization sp3 to which X is connected. Is there any doubt, Madiha, Darshan, Ayman?
No, sir.
That's good. Now the next is benzylic. Benzylic is also part of sp3CX, and we know that benzylic halides. We are talking about benzylic halides, and you already know that each carbon or every carbon in benzene is sp2 hybridized. So we cannot directly do this in this classification because X will be connected. Now X will be connected to sp2 hybridization, which is wrong because this is the classification in which X is connected to the carbon which have sp3 hybridization. So it will be like this. So you can see this is sp3 hybridization and adjacent carbon is doubly bonded. Adjacent carbon is doubly bonded. This is known as benzylic halide. Can anyone tell me degree of this halogen? Can anyone tell me, please? Let me know when you are done with this. And degree of degree of each halogen. These are all example of benzylic halide, which is very easy. Please do let me know when you are done with this. Very good. Darshan, you are also done, right? Madhya, this will be primary. This will be secondary, everyone. And this will be tertiary, right? Very good. Okay. Now come to the third classification. That is, this has further subpart, two subpart. And the third classification is compounds containing sp2CX bond. Compounds containing sp2CX bond. So basically, in this doubly bonded carbon is directly connected with X, or X is directly connected to doubly bonded carbon. In this, we have first vinylic halides. Vinylic halides. So you can see what is vinylic halide. So basically CH2 double bond CH2 directly connected X. This is called vinylic halides. And if we have like this structure, you can see this is vinylic halides. And the second classification of this subpart is aryl halides. Aryl halides. It is also the part of sp2CX bond. That means basically you can see this is a benzene and it is sp2 hybridized, so X is directly connected to this, so it is aryl halides. Also we can write like this, CH3 is here, X is here, this is also aryl halides. Aryl, that means benzene, X is directly connected to benzene ring, that is aryl halides, and vinylic halide is X is directly connected to Double bond is also here, but it is aryl. That means aromatic compound. Aromatic compound. Other than aromatic compound is like this. That is vinylic halides. Let me know when you are done with this. Everyone done with this? Very good. Madhya? Aman? Madhya, are you done with this? Just after this. Basically, in this batch, Darshan, it wasn't. This was the first class. This is the first class basically in this batch. We have studied about this in backup class, I think. Write the IUPAC of following and strengthen your IUPAC name or IUPAC because it's very easy. CH3 whole twice. CH. 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 Wait a minute, please. Just do this four nomenclature, then we will move to the nature of bond. 2-chlorobutane. Aman, any answer for the second? Sorry. Any answer for the first? Are you pick?
So I'm
Madiha?
doing it.
Okay. Is it the answer for second one? Okay. I'll check it out. Send all the answers. Madiha, any answer? You are not audible. Am I audible? Aman, Darshan, Madiha.
Yes, sir.
Okay. Aman, any answer for the first one?
Sir, 2-chlorobutane.
Okay. Madiha, what is your answer for the first? Good. Now see, I'm going to explain the first one. It is wrong answer, I mean. So if you are going to expand it, it will be CH. And then here it is CH3. And again here it is CH3. Now this is CH. Cl is here and CH3 is here. If you are going to number it, it will be 1, 2, 3, 4. So the name will be 2-chloro, alphabetically 2-chloro, 3-methyl, 2-chloro, 3-methyl butane. Aman, is that clear?
Okay, sir.
How it can be 4-methyl? Darshan? Okay. Now, if you are going to name it, it will be just expand it for correct answer. It will be CH and then CH3 is here. Then CH and C2H5H is connected to this carbon. That means C2H5H, C2H5. That means CH2CH3. And here it is Cl. And here it is Cl. So the structure is something not that much good. So I'm going to make it more easy. CH3, CH2, CH2, then CH, then CH3, and then CH2. Oh, wait a minute. Yes, CH, and then Cl, and then Cl. You can see. Am I audible to both of you? Now, going to numbering it. So if you are going to number it from left to right, the substituent will come at third position. And if you are going to numbering it from right to left, the substituent will also get number 3. But when it will be same position, we are going to do on the preference. We will give preference to alphabet like chlorine, chloro. C will be first, then methyl M. So we are going to number it from 1, 2, 3, 4, 5, 6, and the name will be 3-chloro, 4-methyl, 4-methyl, and then hexane. Is that clear? Amen. Any answer for the third, fourth? Are you done with this? Are you done with the third one? Please do respond so that I will explain.
Sir, can you explain?
So I'm going to expand this structure so it will be more easy to calculate. See, write the IUPAC. CH double bond CH, then C, and then Br, and then CH3 twice. So it will be like this. The structure will be like this or not. So whenever bromine is here, this is as substituent. We will treat this as substituent. We will give preference to double bond. So 1, 2, 3, 4, 5. If you are going to number it from right, double bond will get lowest position. That's why we are going to give number it from left side, left to right, so that double bond will get lowest position. So the name will be 4 bromo, 4 methyl, pen 2 ene. Is that clear? Are we done with the fourth one? Any answer for this? Darshan? Amen?
No, sir.
Okay. See, if you are going to number it from here, double bond will get second position. And if you are going to number it from this carbon, double bond will get the first position. So we will number it from here, and the name will be 1,2 dibromo. 1,2 dibromo prop 1 ene or propene. Directly we can write. Are we done with this? Please do write it.
Okay, sir.
Both of you, nomenclature is very bad. Your nomenclature, and it's very important to learn nomenclature because it is very easy, and it is these marks are free. Like it is easy to score from nomenclature. Can I change the slide, Darshan? Now I'm going to give you some more questions regarding this double bond and see what you have done. I think I already had given in the previous class. If it is so, please let me know. If I had given you in the backup class this question, please let me know. The nomenclature of this is very easy, but the representation is slightly vast, but it's very easy. If you are going to rearrange it, or you can, if you can read it easily, then you can easily. Please do this 3. Aman, please do let me know the answer of this. Darshan. Darshan, are you there? So what is the answer for the first? I'm waiting for your answer. No, 2-bromo. That means you have done numbering from downward 1, 2, 3, 4, 5 like this. Yes or no? Please. Yeah. Wait, sir. I'm waiting. Okay, take your time, but do it correctly. It's very important nomenclature. For bromo pentoin. Very good. Do the next one. Any answer for the second one? This is done. Three bromo. No, it's wrong. 3-bromo butane. Oh, okay, okay. Take your time. No problem. One, two, three, four. So 3-bromo 2-methyl but 1 in na? At the first carbon it is. So the name will be 3-bromo 2-methyl but 1 in, not 2 in. Very good. Do the third one along with third one. I think in the next class we will go for preparation. Are you solving the assignment? do all this. Very good, Darshan. Very good. Are you done with the fourth one? Okay, take your time. Darshan, see 4 bromo 3 methyl bute 2E. If you are going to number it from here 1, 2, 3, 4, 4 carbon you will get in parent chain along with this branch and this branch. But if you are going to number it from here, double bond will get to second position, and from this side numbering you will get second position. So we will give preference to this. So the name will be 1 bromo and then 2 methyl and then bute 2E. Are you getting my point, Darshan? Do the last 2 questions and then we will move to the. Okay, no problem. It's wrong again. If you are going to give number from here, you will see double bond will get position second and bromine will get fourth position. But if you are going to number it from here, 1, 2, 3, double bond will get second position again, but bromine will also come. Bromine will also have lowest number. That's why we will do from this. Butene, it will be butene, but it will be 1 bromo butene, not 4 bromo butene. Let me know the answer of last, and then we will do nature of CH bond. Not 1 bromo. Again, you are mistaken. If double bond is there, we are going to prefer it. If you are going to give numbering 1, 2, 3, you can see double bond will get second position. If you are going to number it from here, double bond will get first position. In this case, from both direction, double bond will get second position. But if you are going from downward, you will have bromine as well at lowest position. That's why I did it from lower to upper. Are you getting my point? So the name will be 3 bromo 2 methyl propene, proponene or propene. Are you done with this? Let me know so that we will start nature of CH bond. Okay. See, before starting preparation, we are having nature of CH bond. As you know that carbon makes 4 bonds like this, and we are studying haloalkane. So you can see CH, and we also know that this X is more electronegative than carbon, so it will have delta negative charge and it will have delta positive charge. So that means polar it will be. Polar, that means charged molecule. You can see X is halogen is more electronegative than highly electronegative than carbon. That's why halogen will attract this bonded electron towards itself. So it will have delta negative and delta positive charge. So there are some questions. We are going to arrange this CH3F, CH3Cl, CH3Br, CH3I in increasing order of A, bond length, B, bond enthalpy, C, bond length, bond enthalpy, and C, dipole moment. I think you can do it because you have already studied about this in class 11. If you are unable to solve this, please let me know. What you need to do is just arrange this in increasing order of this bond length between CH3 and F, between CH3Cl, CH3Br, CH3I in increasing order. First question. Please do write it and let me know when you are done with this. Are you done with this? Fluorine will have higher bond length. See, bond length depends on size. So if we are going to arrange the first one, bond length, for bond length, you can see this is CH3F. Can you tell me in fluorine, chlorine, bromine, iodine, which has larger size? We already know that in group, size increases. Fluorine, bromine, iodine. Iodine is the largest one, so the bond length of iodine will be largest. Yes or no, Darshan? Fluorine is small, so the bond length it will make will be small. I meant that fluorine, bromine. I couldn't understand what you were trying to say. Is that clear? But still it is wrong because you put bromine first, then chlorine. Are you getting my point? FBrCl and then this. That is why I mistake. Okay. Now see the second one, bond enthalpy. Always remember that bond length inversely proportional to bond enthalpy. The one with the shortest bond length will have generally high bond enthalpy. So it will be CH3F, then CH3Cl, then CH3Br, then CH3I. This will be your answer. Are you getting my point, Darshan? Please write it. Very good. Now see about dipole moment. Dipole moment. Bond enthalpy is basically, you can see energy required to break the bond or formation of bond. After bond formation, there will be release of energy, that is known as bond enthalpy. Dipole moment is denoted by mu, which is equal to Q into T. See, the highest dipole moment will have CH3Cl, and then see after CH3Cl it is CH3F, and then CH3Br, and then CH3I, the loads. See, dipole moment depend upon charge as well as distance, bond length. It is maximum or highest electronegativity, but the distance will be lower. So chlorine we will give preference to which, when experimentally it was seen that CH3Cl will have the highest dipole moment, then F, then Br, then I. Please remember it. It's very important. Okay. Now I'm going to give some questions for homework from NCERT. NCERT exercise. So you are going to do question number 1, question number 2, question number 3, question number 4, question number 4. Up to 4 you are going to 4, and then 6 it is. These 5 questions you are going to do from no. And okay, this whatever I am teaching here, right? Darshan, you are talking about this. Which solution? You don't write the note. You don't note the solution, or you don't write the solution during the class. Oh, that's the chapter.